Assalamu alaikum. I am Mohammad Jahangir Alam, lecturer in physics. I welcome you all in my online class in behalf of Milestone College. Dear student, thanks to Almighty that He has given me the ability to take this class. Here I also hope all of you are well and carrying on your regular studies, staying at home. Right, dear student, today we are going to discuss some very important creative question for your upcoming exam. Today we will discuss from physics first paper chapter 10, that is the chapter of ideal gas and kinetics of gases, right. Mainly we will discuss the creative question regarding Boyles law or application of Boyles law, right. Dear student, so let's start our classes. Right, dear student, here is our first creative question. And the stem of the question, they said that in physics lab, a student observed that while an air bubble comes from the bottom of a water-filled water vessel, its volume increases to 1.1 or 1.1 times than the previous volume. Later on, the student mixed a liquid in the water. As a result, the density of the mixed water becomes double of pure water, and 1 atmospheric pressure is 10 to the power 5 Pascal. In question C, they said that determine the depth of the water vessel, right. Dear student, we can consider the situation like this figure. Suppose here is a water vessel, it's filled with water. When an air bubble remain at the bottom of the vessel, if it releases, then it come to the top of the water vessel, right. When it comes to the top of the water vessel, the volume of the air bubble increases to 1.1 times than the previous volume, because you can realize that if the air bubble remain at the top of the water vessel, then it feels only the pressure due to the air column, that is only for atmospheric pressure. But when it remain at the bottom of the water vessel, it feels pressure due to air plus water, okay, because air is exerting pressure on the top of the water, and water is also pressure on the air bubble. So it feels pressure due to two items, one is water and another is air. So definitely the volume of the air bubble will remain smaller at the bottom of the vessel, and it will be larger at the top of the water vessel. So we have to determine the value of the depth of the water vessel. So here we can write that let the depth of the vessel be h, right. If the depth of the vessel be h, then the height of the water column also be h, and pressure due to water, pressure due to water, if denoted by Pw is equal to h rho g, right. So pressure at the bottom of the vessel, if denoted by P1, so P1 is equal to P plus Pw. Here P means atmospheric pressure and Pw means pressure due to water. Now if volume of bubble at the bottom be V1 is equal to V, therefore the volume of the bubble at the top be V2 is equal to 1.1 V, because they said that the volume increases to 1.1 times of the previous volume, right? So from the Boyles law we can write that we know P1 V1 is equal to P2 V2. That is shown the value of P1, that is pressure at the bottom of the vessel, is P plus PW. So we can write, or P plus PW into V1 means V is equal to P2. P2 means pressure at the top of the water vessel, and you know at the top of the water vessel pressure is only exerted by air. So it will be P, which is indicated here P, and V1 means V2 means 1.1 V. So we can write if we cancel out V from the both sides, we will get P plus PW is equal to 1.1 P, or PW is equal to 1.1 P minus P, that is 0.1 P, or PW means pressure due to water, and this can be expressed as H rho G. Here H is the depth or height of the water column, rho is the density of water, and G is acceleration due to gravity, is equal to 0.1 P. Here P means atmospheric pressure, or H is equal to 0.1 into the value of P is 10 to the power 5 divided by rho into G. So using the value of rho and G, 0.1 into 10 to the power 5, rho means 1000 into 9.8, and after the calculation you will get 1.02 meter. Dear student, this is the final answer for question C, that is depth of the water vessel was 1.02 meter. Okay, dear student, in question D they said that what will be the change in volume of air bubble while comes to top from the bottom of the vessel after mixing liquid. You know, they said that when the student mix a liquid with water, then the density of the water become double that of the pure water, right? Since the density of water changes or mixed water changes, so the pressure exerted by the mixed water will also changes. So in that case the change of volume will be different. So similarly, if we consider, let the volumes at the bottom and top of the vessels be V1 and V2 respectively. Right? So we have to show a relation between V1 and V2, that is what will be the change in volume. The pressure at the bottom of the vessel, if denoted by P1, then P1 is equal to P plus PW, that is atmospheric pressure plus pressure due to water, and that at the top of the vessel be P2. So P2 is equal to P only, that is at the top of the vessel the air bubble fills only atmospheric pressure. So according to Boyle's law we can write P1 V1 is equal to P2 V2. Okay. So value of P1 is equal to P plus P W into V1 is equal to P2. P2 means P into V2, right? So from the expression we can write V2 by V1 is equal to P plus PW divided by P, right? Or V2 by V1 is equal to, dear student, you know P is the atmospheric pressure P and PW is the pressure exerted by water column, which can be expressed H rho G divided by P. So using the value of P, you know the value of P is 10 to the power 5 plus H. H is 1.02, which we have got previously in our previous calculation. Rho means density of the mixed water. You know the density of pure water is 1000, but that of the mixed water they said that it will be double of the pure water, so it will be 2000 and G is 9.8 divided by P means 10 to the power 5. Okay, 1.1999 or 1.2, right? So dear student, here V2 by V1 is equal to 1.12. So we can write that V2 is equal to 1.2 into V1. So from the expression we can say that when the air bubble come from the bottom to the top of the impure water, that is mixed water, then its volume will be 1.1 times than the previous volume. That is V2 is equal to 1.2 into V1. That is final volume at the bottom of the water vessel of air bubble will be 1.2 times of the volume that was in bottom of the water vessel, right? Dear student, I hope you got it. Now we are going to see our next creative question. Okay, dear student, here is our second creative question, and the question describe almost the same thing in our previous creative question. When an air filled balloon is taken to the bottom of a lake having depth 40.81 meter, then its volume become 1 liter. That is, when an air balloon taken to the depth of a lake, due to the pressure, the volume of the air bubble become 1 liter, right? At the bottom of the lake, more 1 liter gas is inserted in the balloon and then released. Taking to the balloon to the at the top of bottom of the lake, more 1 liter gas is inserted in the balloon. That is, total volume of the balloon will be 1 plus 1 or 2 liter. Then the balloon was released. Okay, and 1 atmospheric pressure is 10 to the power 5 Pascal. Acceleration due to gravity is 9.804 meter per second square. Our first question is, what was the initial volume of the balloon? That is the volume of the balloon before taken to the bottom of the lake, okay, or the volume at the top of the lake. Here the depth depth h is equal to 40.81 meter. Atmospheric pressure which is denoted by P. P is equal to 10 to the power 5 Pascal, right? So pressure at the bottom of the lake, if denoted by P1, P1 is equal to P plus PW, that is atmospheric pressure plus pressure due to water, and which can be expressed as P plus H rho G. Okay. Pressure at the top of the lake, if denoted by P2, P2 is equal to P, which is 10 to the power 5 Pascal, right? Volume at the bottom of the lake, if denoted by V1, V1 is equal to 1 liter, which is mentioned here 1 liter. Okay. So volume at the top of the lake, V2 is equal to what? Dear student, here we use the same expression, that is, we know P1 V1 is equal to P2 V2, right? Here P1 means P plus H rho G into V1 means 1 liter is equal to P2 means P into V2. So we have to determine the value of V2, or V2 is equal to P plus H rho G into 1 liter divided by P. So using the value of this expression, P means 10 to the power 5 plus H means 40.81 into rho means 1000, density of water G is 9.804, okay, divided by 10 to the power 5. So after the calculation, you will get 5 liter. Okay. So this was the initial volume of the balloon, that is, volume of the balloon was 5 liter at the top of the lake. Okay. In question this said that if the maximum capacity of the balloon is 9 liter, that is, the balloon can contain maximum 9 liter of gas or air, then whether the balloon will remain intact or not. Because at the bottom of the lake 1 more liter gas is inserted in the balloon, that is, it contains 2 liter of air or gas at the bottom of the lake. But when it was released, the balloon will come to the top and the volume of the air balloon wall will be increased due to the decrease of pressure. So if the volume of the balloon at the top is more than 9 liter, then it will be blasted, or if the volume of the air balloon remain less than 9 liter, then it will remain intact. So first we have to determine the final volume of the balloon at the top of the lake after inserting 1 liter more air into the balloon. Here the initial volume V1 is equal to 1 plus 1 or 2 liter, right? So initial pressure, which is denoted by P1, so we can write P1 is equal to P plus H rho G. Okay. Here final pressure, here final pressure means pressure at the top of the lake. If denoted by P2, so P2 is equal to P only, because there the atmospheric pressure exists only. So final volume V2 is equal to what? First we have to determine the value of V2, then we will compare the volume with 9 liter. Dear student, we know P1 V1 is equal to P2 V2, or V2 is equal to P1 V1 divided by P2, right? So using the value P1's mean P plus H rho G into V1's mean 2 liter, that is P2 means P, and using the value of this expression, P means 10 to the power 5 plus H means 40.81 into rho means 1000, G 9.804, right, multiplied by 2 liter divided by 10 to the power 5. Okay, and after the calculation you will get 10 liter. Dear student, this will be the final volume of the balloon or volume at the top of the lake. Here V2 is greater than 9 liter, that is the volume will be more than the maximum capacity of the balloon. So from the conclusion we can say that the balloon will be blasted or it will be not intact, right? Dear student, I hope you got it. You have to practice this type of creative question for your upcoming exam, and I hope this creative question will help you a lot. If you practice this type of question, I think you will do better in your exam. So dear student, good wishes for all of you. May Allah bless all of you. Assalamu alaikum.